In this video, we are going to discuss about implementation of logic gates using a decoder. Implementation of two input logic gates using decoder. So what is a decoder? Decoder formula is n is to 2 power n with one enable pin. This is your input, n is your input, and 2 power n is your output. So if I draw the diagram, since I have n is equal to 2 input logic gate, I need to implement 2 input logic gate, n values equal to 2. So how many inputs are there? You have 2 inputs. Let me name that one as A and B. So 2 is to 4, 2 power 2 is 4 with one enable pin. The enable pin must be 1. Okay, in order to activate this decoder, if enable pin is 0, the input will not reach the output. So you have 4 outputs. So let me term that one as I0, I1, I2 and I3. Okay, so if I draw the truth table, AB is your input. Okay, 0 0 0 1 1 0 1 1, and I0, I1, I2, I3 is your output. For the enable pin is equal to 1. Okay, so if that is the case, my I0 should be equal to 1. Okay, I0 should be 1. Okay, for 0 0 input, I0 should be 1 and the rest of the value is 0 0. Likewise for 0 1, I1 should be 1, rest of the outputs are 0 0. For 1 0, I2 must be 1 and the rest of the outputs are 0. For 1 1, I3 is 1 and I0, I1, I2 is equal to 0 0. Okay, so what is the value of I0 now? I0 is equal to A bar B bar. I0 is 1 for the value of A bar B bar E. Okay, since E value is always 1, I0 is equal to A bar B bar. So what is I1? I1 is equal to A bar B into E. Since E value is 1, A bar B into 1, that is nothing but A bar B. So similarly for I2, what is I2? I2 is equal to A B bar. What is I3? I3 is AB. Okay, so suppose if I want to implement OR gate. Okay, so if I want to implement OR gate, so the question is they are asked to implement the I need to implement this OR gate. Okay, 2 input OR gate using a decoder. So let me copy this one and what is this? This value is A bar B bar, and this is A bar B, and this is A B bar, and this is AB. So you know the truth table for OR gate, right? So what is the truth table for OR gate? A, B, Y. The logic is if any one of the input is 1, output is 1. Okay. So this is a truth table for OR gate. So I can write y of a comma b is equal to summation m 1 2 3, right? 1 comma 2 comma 3. So this is I1, I2, I3. So you have to connect I1, I2, I3, that is 1 2 3 to a OR gate. So this is how we have to get the output for a this is how we have to implement the OR gate using a decoder. Okay. Suppose if I want to implement this two input OR gate using a ROM. Okay, the question is, suppose if I want to implement two input OR gate using a read only memory. Okay, so the similar I have used a ROM that is of 2x4 ROM. Okay, so how to implement this? So here I must employ a MOSFET. Okay, so this is your VDD and this is your MOSFET. Okay, so you can see whenever for the to get the output of the OR gate. So if this is a N MOSFET, so whenever this I1 is 1, these three MOSFETs I1, I2 and I3 is 1. These three MOSFET will becomes turns on, and therefore the VDD goes to this ground. Okay, the VDD will passes through the ground, so you will not get the 1 value at the input of the NOT gate, so you will get 0 at the 0 value here. Though I have given VDD, since the VDD value passes to the ground, since the MOSFET turns on, it goes to 0, so my output goes to 1, y is equal to 1. So this is how you have to implement the two input OR gate using read only memory. This is nothing but read only memory. So instead of OR gate, I have connected a MOSFET. Okay, so the MOSFET get turns on and my VDD goes to 0. Okay, thank you very much.